Okay, this is going to be IPv6 for CCNP session 1. We're going to have 2 or 3 sessions, haven't really decided yet. This first session will be pretty basic. It's going to cover IPv6 addresses. We're going to look into some debugs, specifically the neighbor discovery. IPv6 neighbor discovery, it's kind of like debug ICMP. We'll go into making tunnels. So you're actually going to tunnel IPv6 over IPv4. And what's going to happen here is we're going to make the inner triangle, actually the whole thing is going to be IPv4. And we're going to pop IPv6 on R1 and R6 and get a tunnel going through it. So we'll probably run like EIgRP everywhere for our routing protocol for IPv4. If we have time, we'll get into access lists. Very, very easy. And actually, with access lists, you'll notice when we first start messing with them that you can use the slash notation in IPv6 access lists. And it's also, the syntax is very easy. For IPv4 access list, it was IP access list. For IPv6, you probably guessed it, it's IPv6 access list. So, not too bad. And then for the next session, we'll do static routing and the various routing protocols. So RipNG, EIgRP, OSPF version 3, and that should just about cover it. And if we need a third class, we'll go for a third class. Okay, looking at our topology, this is the topology that you all know and love. This is topology 11 with our triangle in the center, 2 routers hanging off the left side and 2 routers hanging off the right side. So just make sure that is up and running. You can go to R3 and ping all 255s just to make sure that it's got next hop connectivity. So I'm going to do that. Go on R3. Ping 255, 255, 255, 255. And we have some stuff coming back, so that's good. And I'll also show you the IPv6 version of that command. Okay, first order of business. Let's get a routing protocol running on all of these routers. Let's pick, what's a good one to pick? Let's pick EIgRP. So on one of the routers, who remembers how to do EIgRP? Dirt basic EIgRP, throw every interface into the routing protocol. Yep, that looks pretty good. Router EIgRP1, no auto, network all zeros. And just do that on every single router. If you want, go ahead and do Notepad to speed things up. And just type in the chat window when you are ready after you've popped EIgRP on all your routers, and you should have routes coming through EIgRP. So just verify with show IP route. Right, so the extreme ends of your network, you've got router 7 on the right side and router 2 on the left side. So if you can ping all 2s, then you're good from router 7. So that ping will take you from this side all the way over to the loopback on router 2. Alright, so even something this simple, if you remember back maybe, let's say a year ago, maybe perhaps when you first started this meetup, remember how tough that was? Just trying to get connectivity from one side to the other. Now it should be really, really simple. Almost like you're sleepwalking. Alright, anyone still configuring EIGRP? Okay, we are going to dive right into it. We'll start on R1 right here. We're going to just start configuring some IP addresses on R1. Let's start with fast01. Fast01 on R1. Now, I'm assuming that maybe you've read just a little bit about IPv6. If not, don't worry about it. We'll get through this. We'll kind of make it up as we go here. Now, right now, your router is configured for IPv4. All right, and so first thing we kind of want to do is we want to enable IPv6 routing on R1. And to do this, we do IPv6 Unicast routing. Pretty easy command to remember, IPv6 Unicast routing. And let's exit out of there. Let's start a debug. So this debug is debug IPv6. If you do a question mark, you got lots of cool things, but the one we're interested in for now is ND for neighbor discovery. You can kind of think of IPv6 neighbor discovery as a kind of an active version of ARP, Address Resolution Protocol. So when you fire up an IPv6 interface, it will make an address, it will try to find others with the same address, and if it does, it will do what's called duplicate address detection and basically say, well, I can't use this address, someone else already has it. And it does a couple other things. But the main thing is finding out if others have a duplicate. So debug IPv6 neighbor discovery. Go into the interface fast01. And watch this. Let's just do IPv6 enable. We know the interface is already on because we're running IPv4 on it. So IPv6 enable. And things start flying, right? And do a UAll to stop it. Okay, so let's see what we got here. NS stands for neighbor solicitation. So what happened here was we turned on IPv6 on the interface. The interface makes up an address, an IPv6 address. Starts with FE80, and this is what is known as a link local address. A link local address means that it's only good for this link right here. So in between fast01 and fast00 on R3, that's where it's good for. Link local. FE80 is the telltale address for that. And you could see here that if we continue on, so it basically says this. It says, I would like to use this address. Like, I think this address is cool. I would like to use it. And you can see it's FE80, and then it's got this stuff behind it. : means there's a bunch of zeros. Then there's C004, blah, 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 blah. DAD, duplicate address detection. So what happened is no one else says they have FE80 in that address. So it says, okay, well, you're the only guy, you're unique. NA, neighbor advertisement, you're telling everyone that you exist on that link. And then the link comes up. And here's what's cool. RA stands for router advertisement. You're telling people that you are a router with that IP address. So if we take a look at this this stuff that comes after FE80, now your number or your number and letters will be probably different. So whatever it is, just you might want to copy it to Notepad or whatever. But if I show interface fast01, you're going to see something interesting. If we take a look at the MAC address here, and we take a look at the MAC address there, do the MAC addresses look somewhat similar? Or does the MAC address look similar to the last part of the IPv6 address? It's probably the better question to ask. Well, we can pop it into Notepad, right? Or I don't like using Notepad. Let's pop it into good old Notepad++. So I'm going to do that. Okay, so that's the difference there. The top one is the IPv6 one, and the bottom one is the MAC address. Let's split this apart. This MAC address right here, we'll cut it down right in the middle, and we'll put it kind of like there. Now you see right here, you have a :1. Now in IPv6, we can shorten these numbers up, these addresses, because normally addresses will have a whole bunch of zeros. And in each IPv6 address, in each part, there are 4 hexadecimal numbers. So right here, you're seeing FE94. Circled in blue, FE94. Now right here, this 1, that 1 is actually 0001. It's got 4 digits there. Over here in the front, I've got 9FF. Second part right there, 9FF. There's actually a 0 in front of that to give me 4 digits. So now if we kind of line these up, starting to look a little bit more interesting. That IPv6 address that it made is almost like a MAC address. Now what's what's in the middle here? What did IPv6 put in to kind of fill in the space? So MAC address, how big is a MAC address? .48, yeah. 48 bits. Now in IPv6, the total part is 128. 128, now if you slice that in half, that's 64. So if we're trying to fit 48 into the second half of an IPv6 address, we have to add some stuff. And this is what we add. We add in FFFE. So it chops up the MAC address, pops in FFFE, and then this part's a little different. This spot right here, it went from a 2 to a 0. So what happened there is it changed the number 2 into bits, and then it flipped it. So it flipped the 1 into a 0. And that's how we got 0. But for the most part, it looks pretty much the same, except you get the FFFE, and you got instead of a 2, it turned into 0. In other cases, it'll turn from a 0 to a 2. It's just, it gets flipped. And all of that was done just by doing IPv6 enable. That's it. So let's go to the router, R1, show IPv6 interface brief. Show IPv6 interface brief, hit enter. And so just by turning IPv6 on, you get a link local address, and also it's auto-configured with what's known as the EUI64 type address. So it takes your MAC address, chops it up, adds FFFE, and you're done. And it also does the bit flip. So pretty much auto-configures itself. So we turned on IPv6 over here. Here's what we're going to do. We're going to go to R3. We're going to turn on IPv6 on fast00. But before we do that, we're going to predict what that EUI64 address will be. We're going to know exactly what's going to come up. So let's go to R3. And let's end out of there. Show interface fast00. So let's get the MAC address. Now your MAC address is probably going to be different, so you're going to just look at mine, or solve mine and then also solve yours. And I'll keep this up. So that's my MAC address. Okay, so if we want to turn our MAC address into an IPv6 address, let's copy this up here. Okay. First order of business, what do we do here? We want to predict what this IPv6 address will turn into. Flip the 7th bit. You could do that first. Okay. So before we looked over here, this 2 turned into a 0. So here it's probably going to be the same thing. Okay. And add FFFE in the middle, right? So boom, boom. FE, and I think we should be done, right? I personally, it is preference, I chop it up, add FFFE, and then I flip it, but you can flip it and then add the FFFE, right? Now, if you have a different MAC address, which you probably do, go ahead and figure it out for yourself. And after you've done it, go to R3, do IPv6 Unicast routing, turn it on, go into interface fast00, IPv6 enable. Then show IPv6 interface brief, and that should match that, what you got in Notepad++ or Notepad. Of course, there's a FE80 in front of that, but let's see if we got it right. FE80, C006, okay, leading 0 we could take out, that's fine. 9FF, yeah, looks pretty good. So you should be able to predict MAC addresses into EUI64 addresses. So all of you going for CCNP route, this is a necessary skill. Any problems with that? So I know IPv6 are kind of a pain in the butt to type in. There's a lot of colons. You'll be typing in double colons. You'll be typing in a lot of zeros. Believe it or not, there is actually a keypad that helps you type these out. It's not a joke. It's not April Fool's joke or anything like that. It is called the IPv6 Buddy, right there. And let's take a look at what this is. This IPv6 Buddy has A, B, C, D, E, F. So for the hexadecimal letters, the 0 through 9 just like normal. It's got a dot. It's got a colon in the bottom right corner. It's got the double colons. And so it's pretty cool. It is only, I think it's 20 bucks. I am very tempted to buy this. Yeah, it's 20 bucks. Then you can buy a 10 pack for 18. Well, they include shipping and handling, so it's not too bad. Group discount, yeah. Yeah, you're right. These obviously professional models. All right. So we've got the old IPv6 address, the address for our one side. So what we could do is we could copy it down. Actually, you could put an FE80 in front of there and copy it into your clipboard, just Control C. And we're going to try to ping it from R3. Now this is where things get kind of interesting. So if you ping and you paste in that address, you're going to see that it's basically looking at you going, what the hell's going on, right? Actually, I typed it in wrong. So FE80 : colon means you're ignoring a whole bunch of zeros. So it's asking you for an output interface. The reason it's asking you for an output interface is for link local addresses. You're on router 3. You could have the same link local address for every interface. So FE80, whatever, you could have the same one on all 3 interfaces. And that's because FE80 is a link local address. This is kind of what trips people out. Okay, so we know that it's out fast 00. So let's say fast Ethernet 00, and we have a success. We can ping from one side to the other. So we have a link local here. We have a link local here. We can send a ping from one side to the other. So just by turning IPv6 on, we're good. Does this remind you of any protocol or operating system in terms of networking? Just turn it on, you get an address, and you're able to reach the other side. No DHCP at all. So this is you may have seen it in Microsoft when you start up a computer that's not connected to the network. Your Ethernet adapter will get a 169, I think it's 169.254, if I'm not mistaken. So 169.254, and it'll just pick something, right? And so if you want to do a crossover cable between two computers, you boot them up. Both of them are going to get 169.254. You should be able to ping each other and transfer files, do drive mappings, and that type of stuff. That is a very good interview question if you are weeding out CCNA and CCNP candidates. Throw them two laptops, throw them a cable. Hopefully it's a crossover. But, throw them a cable and say, hey, transfer one from the other. Okay, for those of you who did that on the link local and the EUI64, for how many of those watching was that brand new, like absolutely brand new? You've never seen that before? Okay. So that's a lot of people think IPv6 is scary. They don't like it. And yeah, the numbers, you're looking at numbers and letters at first, but it's not really that difficult. It's not too bad. Okay. Everyone was able to ping from one side to the other, right? With IPv6. Okay. So trying to remember this address, the FE80 is not that bad, but this MAC address is pretty, it's pretty horrible. You don't want to be remembering that. So we can we can change that. We can make it very simple. So let's stay on R3. Let's do this. Let's go into the interface fast00, and we'll do IPv6 address FE80 ::3. And then let's see if we can get away with putting a space and then say link local. So IP address FE80 ::3. And I'm just using 3 because this is router 3. And we'll say link local. Now if we show IPv6 interface brief, you'll see we've changed that link local address, that big, long, ugly one, into FE80 ::3. So what that means is it's FE80 and then a whole mess of zeros and colons, and it ends in 3. Going to do the same thing on the other side, router 1. And you guessed it, we're probably going to use FE80 ::1. So going to interface fast01, IPv6 address FE80 ::1 link local. And now when we ping, should be really easy. FE80 ::3. We say that we want to go out fast Ethernet 01, and we have a good ping. So now we don't have to remember all that junk. Just remember the other side is FE80 ::3, and we're good. Okay, and just to prove to you that your link local address, yes, you actually have to type in fast Ethernet. You noticed that, right? So yeah, if you ping FE80::3, it says output interface. If you try to do fast 00, it goes nope, doesn't like it. So you have to actually do fast Ethernet, the whole thing, and then the number. Yeah, it's kind of bad. I believe if you have access to iOS 15.1 or 15, I think they might have fixed that, but I'll have to verify. Actually, if you have a chance to play around with iOS 15, it is pretty cool. A lot of things have been polished up. Okay, so just to show you that this link local address can go on multiple interfaces, let's go back on R3. And so we know that we have fast 00, fast 01, fast 10. So we'll go on interface fast 01, IPv6 address, FE80::3, link local, no shut, interface fast 10, just hit the up arrow, get that IPv6 address back, and no shut as well. And now when you end out of there, show IPv6 interface brief, you'll see you have the exact same link local address on all three interfaces. It's pretty wild. And so that's why you need to specify which interface you're going out of when you do those pings. Okay, so these link local addresses, they get you from point to point, but they don't get you on the internet. So it's just like on your Microsoft machine with that 169.254 address, you're not getting on the internet with that. So we're going to have to give your routers a global address. And that's not too difficult. It's actually very easy. We'll go to R1. So one thing to keep in mind is you always get a link local address, no matter what. You get a link local address. Whether you type it in or whether the router makes it, you're going to get a link local. Global addresses you have to type in. All right. So let's go into interface fast01. So we're going to pop a global address on this interface right here. And the address we're going to pop in is, let me think here. We'll do 3000::1. And then we're going to have to specify the mask, or how many prefixes to use, or how many spots to use for the network. And we're going to say 64. So what this means is I'm chopping that in half, and I'm using the last 64 bits for my internal hosts. Still a lot of bits for hosts. Whatever that number comes up to, it's going to be much bigger than my normal network, right? Now in real life, the numbers that they have are going to start with, I think they're at 2001, and I don't know if they've actually gotten to 2002 yet. And then when they start getting close to 2002, they'll start doing 2003. So we got plenty of numbers left. So R1, fast01, IPv6 address, 3000::1. Then if you do the question mark, it's saying, okay, well, I'm expecting a slash. We'll do 64. Enter. And so now if you show IPv6 interface brief, you'll have both a link local, which you're going to get a link local no matter what, and you'll have a global address, 3000. 3000::1. Okay, I'm going to go over to R3, give that guy an address, and you probably guessed it, we're going to do 3000::3. So interface fast00, IPv6 address 3000::3/64. Show IPv6 interface brief, and it should be good. Okay, so Sheldon asks, how many configured global IP addresses, IPv6 addresses can you have on an interface? Practically unlimited. Well, whatever the router will support, but for intents and purposes, a lot. Yep. And so, yeah, that does bring up a good point. If for some reason you think you messed up and you go back into the interface and you go, okay, I'm just going to enter in a new IP address. So let's say I actually wanted 3000::4/64, and you type that in. Now what's going to happen is when you show IPv6 interface brief is you will see several addresses because you have to nuke the old one. If you want to just completely start over, you have to nuke the old one and retype in the one you want. Another option that you have, if you just have a whole bunch of configuration on that interface, is you can always do the trusty default interface fast00, and that resets the interface. It clears out all the configs for that particular interface. So Jim has a question, does the mask or slash notation have to match in order to ping? No, it does not. So you don't necessarily have to have /64s on either side, just as long as the numbers match. So one side can be 3000::1/64, the other side can be 3000::3/112, and it should still work. Okay, so we popped in a global address on both sides. Let's see what happens if we ping the global address, ping 3000::1, so we know that's on R1. And you can see there we did not have to enter an interface because it already knows where to send that out. And the reason it knows how to send it out is just like an IPv4. So on one side we had 3000. Whoa, maybe I should start over here. So on one side I had 3000::1. On the other side I had 3000::3. Both are /64s. So what happened here is when you did the ping, your router looks at this and it goes, okay, well, here's the slash. I'm trying to ping an address that starts off with the same numbers, so it must be out that particular interface. I'm going to send it out here. Your router in IPv4 does exactly the same thing. So like when you have, let's say 192.168.1.1, and you want to go to 192.168.1.254, let's say, they're both /24s. Well, you slice it here, your router compares the addresses, the network part, says, okay, well, you want me to ping 192.168.1, you must be going out that particular interface. So it's only going to send it one way. So go back to R3. Let's debug. So on IPv4, we did Debug Ip Packet In IPv6, it's Debug Ipv6 Packet. Do the ping again, just hit the up arrow a couple times, ping 3000 : 1, and you'll see something interesting after the ping finishes. You all. So let's see here. 3000 : 1. Source, you're sending from 3000 : 3. Destination 3000 : 1. Fast Ethernet 00. So we're actually good. Okay, so it works pretty much the same as Debug Ip Packet that you saw before, that you've done before. All right. So any questions so far about global addressing, EUI64 addressing? Shouldn't be that difficult. Okay, let's see, DAD and auto config. Okay, so the duplicate address detection here, let's do this. On R3, let's turn on Debug Ipv6 neighbor discovery. Okay, and we will reset our interface. So let's do this. Default interface fast 00. That's going to just wipe it out. Okay, so we're wiping it out, and you can see the neighbor discovery goes nutso. So let's see what we have here. It says 3000 : 4 down, delete it. 3000 : 3 is down, delete it. Sending the final RA, which is the router advertisement. Basically, it's kind of like, see ya, I'm out of here. So we'll go back into interface fast 00. Here's what we're going to do. We're going to try to give it the same address. So IPv6. Now I have a duplex mismatch. Let's see here. Okay, we'll do speed 100, duplex full. And do that on both sides. So go on fast, or R1, fast 01, do the same thing. Sometimes GNS3 does this. Speed 100, duplex full. And that fixes those messages that come up, if you are getting those messages. All right, so back to setting an address. We know that one side is, yeah, your EIGRP will die because we killed our IPv4. Oops, because I did the default interface, right? So yeah, first order business, let's pop in the IPv4 address, so IP address 10.10.13.3, and the /24 mask, and then your EIGRP will come up. All right. So what we're doing now, by putting IPv6 on here, is running IPv4 and IPv6 on top of it, and that is known as dual stack. They're both running, but they don't bother each other. It's fine to run both. Okay, so back to IPv6, what we're going to do is we're going to set an address that's the same as the other side, and we'll see what the neighbor discovery messages tell us. So we're going to set a FE80 : 1, and it's going to be link local. So it's going to conflict with the other side. So see what happened here. Neighbor solicitation. So it's saying, hey, I would like to use FE80 : 1. I received an advertisement, a neighbor advertisement from the other side saying, now wait a minute, I've got FE80 : 1. We are duplicates. So not going to use that. And yeah, if I show IPv6 interface brief, yeah, it's basically saying what network do I belong to. Yeah. So it's a pretty cool feature of IPv6. Let's go back into interface fast 00, change that IPv6 address to FE80 : 3, link local, and we'll add the global address, IPv6 address 3000 : 3 /64. Need that slash in there. It doesn't let you guess on that one. You need to be pretty specific on that. And you can see when we did FE80 : 3, it basically says, hey, I'd like to use FE80 : 3, and nothing came back, so it's unique. Okay, so one cool thing that you can try is, well, I'm going to stop that. So you remember from earlier, I did a ping of all 255s. And so when you do a ping of all 255s, it just goes out and sees who is, all the addresses come back, right? Just pings out all your interfaces, and you have a bunch of replies coming back. The IPv6 way of doing that, just, hey, who's out there on the link, is you actually can ping this multicast address. It's FF02 : 1. This is going to ping all hosts. So FF02 : 1. And you're going to have to specify an interface. So we'll say fast Ethernet 00. And you see right there, we've got a reply coming from FE80 : 1. So that's router 1. Router 1's link local. Okay. Okay, so now that we can get, communication from one router to the other, so that's not too exciting. What's exciting is being able to tunnel IPv6 through IPv4. And specifically what we want to do is we want to assume that this inner triangle right here only runs IPv4, like, most of the world. And in red, R1 and R6 are running IPv6. So the question is, how can we get IPv6 communication from R1 to R6 through a network that only understands IPv4? Right? So the thing we have to do is we have to tunnel it. And there's actually lots of ways we can tunnel it, but what I'm going to show you tonight is going to be the easy one. This is a manual tunnel. So you're going to hide these IPv6 packets into IPv4. So there's manual, there's 6 to 4, and there's another one. It's called isotap. So I won't show you. Well, we might get to 6 to 4 tonight, but I'll at least show you the manual tunnel, and it's easy, you know. So first of all, I'm going to go back on R3 and kill that IPv6 address. Right, so we don't want it there. So interface fast 00. Hit the up arrow a couple times until you get to that IPv6 address and put no. And kill that link local one as well. Put a no in front of that. So now when you do show IPv6 address interface, or show IPv6 interface brief, yeah, we'll kill it from all your interfaces. Fast01, no IPv6 address, FE80::3, and kill it from interface fast10. Okay. So right now, my middle section right here, this is all IPv4, right? Let's go on R6, set up a IPv6 address on fast00. So we want to have these talk to each other. So if we want them to talk to each other, R6 fast00 should have an IPv6 address. So go to R6. And by now you should know kind of how this works. We're going to first turn on IPv6 routing. Unicast routing. Going to go into interface fast00, IPv6 address. We'll do a link local, why not? Gives you a little practice, FE80::6, link local. And we'll make our global, which is 3000:6/64. And it's already no shut, so you don't need to do no shut. So before we do a manual tunnel, let's kind of write out the tasks we need to do, or the commands. So you've probably done tunnels before, interface tunnel 0. So it's kind of like making a loopback. We are going to pop an IPv6 address on there. And so actually what we could have done is, instead of putting an IPv6 on the interface itself, we could have done it in the tunnel. But oh well, we can have multiple, no big deal. We specify a tunnel source that points to IPv4, or either IPv4 or your interface. You're going to do a tunnel destination that's also going to be towards IPv4, so the other side. And then you're going to have to say tunnel mode, the IPv6 IP. So IPv6 inside of IP. Okay, so that's the basic gist of what we're doing here. So the thing to remember is you need an IPv6 address, and you need to specify a tunnel mode. So let's do this. Let's go on R1 side. Go R1. So let's do interface tunnel 0. And let's do tunnel mode first. Tunnel mode, question mark. And you can see there's a whole bunch of tunnel modes. One we want is IPv6 IP. IPv6 IP. And you can see here, we could hit enter there, or you have other options. There's the 64, there's the auto, there's the isotap, there's a whole crap, there's a lot. But for now, we just hit enter. So we have our mode set up. Give it a IPv6 address, so IPv6 address. And let's do 4000 1/64. Tunnel source. I like using interface. So what are we going out of? So if we look at our diagram here, we are saying we are sending this out of fast 00. So tunnel source, fast, or is it fast 00? Fast 01, sorry about that. So tunnel source, fast 01. Tunnel destination. Now this is where people mess up. The tunnel destination is going to be the IPv4 address of the other side. So what's the IPv4 address of the router and the interface you're trying to reach? So you're trying to hit R6. .10.10.56, correct. So sometimes before setting up a tunnel, actually probably most times before you set up a tunnel, you should probably ping that address, because you're going to be in a world of hurt if you can't ping it. But we know we can reach that, so it's going to be 10.10.56.6. And you can see as soon as your destination IP was typed in, your tunnel comes up. Just your side of the tunnel will come up. And so I think we're okay there. If you show IPv6 interface brief, you can see that you have a tunnel. And look at that. What did the tunnel make? What kind of address is that? So we typed in a global address and you got a link local. So remember, all IPv6 interfaces, which includes your tunnel, no matter what, you get a link local address. You always get a link local address. Okay, so we go to R6. We're going to configure the tunnel coming back. So interface tunnel 0, tunnel mode, IPv6 IP. IPv6 address. We're going to say this is 4000:6/64. Tunnel source, we're going out our fast 00. Tunnel destination, we're trying to hit 10.10.13.1, I think. And if you get it right, the tunnel will come up and out of there. And so let's see if we can ping 4000:1. We have a success. At least I have a success. So we configured IPv6 here, IPv6 here. Everything in red is IPv4. And we have basically a tunnel going straight through. Yeah, I could do a debug. In fact, here's where I'm going to do a debug. I'm going to go to R3. And I'm going to have to turn off IPsef. So no IPsef. And the reason I turn off IPsec is when you try to do a debug IP packet, if you have Ceph turned on, you're not going to see too much because it's switching it instead of sending it to the CPU. Okay, so we do debug IP packet. We go to R6, do that ping again. Go to R3. See what happened here. You all. Okay. Let's see. Anything exciting here? I don't see anything too exciting. Oh, it might be, let's see. Yeah, that's a good point. Let's see. Let's go to R6. Let me run a regular IPv4 trace. So trace out 10, 10, 13, 1. Let's see where it's going. So 5, 3, 1. 5, 3, 1. Okay. Yeah, so as far as IPv4 is concerned, we're going this way. So that's a regular IPv4 trace. So it's going here, here, here. 3 hops. Now since this is a tunnel, if we trace IPv6 and we want to go to 4000:1, it's 1 hop away because we're hiding it through a tunnel. Right, so the router's in the center in that IPv4 cluster thinks everything is A-OK. Not a problem. Okay, any questions about a manual IPv6 tunnel? Configuration is not that difficult if you show run. Yeah, absolutely. You could put an ACL on that tunnel to do filtering. In fact, yeah, I think we have time to do it. So that is the configuration right there on R6. We did interface tunnel 0. We popped the IPv6 interface or IPv6 address on it. Did a tunnel source, tunnel destination. These two are IPv4. And then we just said IP mode, IPv6 IP. Okay, so we're going to kill 2 birds with 1 stone. We're going to do some IPv6 static routing, and we're also going to do some ACLs, and then I think we'll wrap it up. So you probably remember when you first got into routergods and you started taking these classes, I taught you how to do default route, right? IP route, all zeros, send it out an interface. Here we can do the same thing from the IPv6 perspective. We can do IPv6 route, and it's going to be : 0. Whoop. Let's see here. Yeah, I hate doing that. : /0. And then just like IPv4, we could do an IP address, or we could say go out the tunnel. So I can say IPv6 route : 0, go out tunnel 0. We'll go on R1. We'll do the same thing coming back. Let's conf t IPv6 route /0, and we're saying go out tunnel 0. So now if you show IPv6 route, that's going to be your static. Pretty much think of it as a default route. It's going to match everything that you don't have a specific match for. So let's try this. Let's go on back on R6. Let's put a loopback on it. Well, it's already got a loopback. It's got loopback 0. We're going to put an IPv6 address on it. And for global address, what global address do you guys like? We'll just pick one. We already used 2000, 3000, and 4000. What's a good one for R6? Yeah, why not? 6000 6/64. Oh, IPv6 address. There we go. So we know that if we do a show IPv6 address, show IPv6 interface brief, that we will have both a link local and the global there. So loopback 0. Whereas that link local looks pretty ugly, but we're not going to worry about it. Okay, so moment of truth. If we go on R1, we go on the other side. Let's go to our diagram first. So on R1, we've got a default route pointing that way for IPv6. On R6, we got a default route pointed out that way. R6, we've got an IPv6 address on the loopback. If I go on R1 and try to ping 6000::6, who can guess what should happen? Yeah, we should get a successful ping because we have default routes pointed pretty much to each other. That ping should get to R6. R6 knows where to throw it because it's directly connected, and then it should send it back out to us because there's a default route. So let's see if that's the case. Go on R1, ping 6000::6, and we have a success. It's pretty cool, right? I mean, the concept for default route is the same. It's just you're dealing with weird, wacky numbers now. Okay, so we killed one bird with we did static routes, default static route, so that was easy. Now let's do an access list. So on R1, do the same ping, so just hit the up arrow, ping 6000::6, repeat 10,000. Right? So you're pinging, everything's good, not a problem. I'm going to go over to R6. We're going to make an access list to block that ping from going to this particular address. And it's actually really, really easy. I think it's simpler than the regular access list. So in IPv6, it's IPv6 access list. So IP access list, IPv6, it's IPv6 access list. Do a question mark, and you have to do it by name. So it doesn't matter what name you pick. Let's see. Lakers suck. Okay, so IPv6 access list, Lakers suck. Now I can't really do anything past that. You hit enter and then you're in configuration mode. Here's where you type in your things. So I'm going to deny IPv6. And we're saying, okay, I'm denying a source. Okay, so I'm going to say deny anything going to 6000::6. So what I'm going to do is deny IPv6 any going towards 6000::6. And here's what's cool. I can use a slash notation. So I could do, if I wanted to match exactly, I could do /128, which would match : 6 exactly. If I just wanted to match that 6000, so everything past in front of the halfway point, I could say, okay, just match the first 64 bits. Now here, just like with the other access lists, I have to permit everything else, or else I'm just going to nuke the traffic. Right? And then exit out of there. And then show IPv6 access list. So it's deny IPv6 any going to 6000. So basically, if it starts with 6000, kill it. Permit everything else in. Now, if you go back to R1, your pings are still going, not like normal, because we haven't actually applied this to any interface just yet. So we're going to go into fast00, conft interface fast00, yeah, IPv6, and yeah, I'm sorry. So in IPv4, you did access list, and then it was access group. In IPv6, it's IPv6, and down here, traffic filter. IPv6 traffic filter. The name of your access list, Lakers suck, and then in. Oh, my pings are still going. Okay, now we get to troubleshoot that. Yeah, let's troubleshoot that. First of all, let's take a look at our access list. Show IPv6 access list. Lakers suck. I have 2 S's in there. I have deny IPv6 any going to 6000. Okay. Sequence 10. I'm letting everything else through. Okay. If I show run interface fast00, I have IPv6 traffic filter Lakers suck in. That looks okay. It's tunneled. Yeah, good point. Good point. Good eye. So we're going to kill that. See, I would have lost those points if that was the CCIE lab. I would have just got killed. So interface tunnel 0. And IPv6 traffic filter Lakers suck in. Let me just go back to R1, see if the ping is still going. Okay, we're still good. Go back to R6. Rock that access list, and now we have, it's pretty cool, A. The heck does A mean? Yeah. A, arg. Yeah. It's ah. So that's a little bit different. Okay, so we definitely are matching something. So let's take a look at, let's Google that. So we go to Cisco, IPv6 ping, AAA. Ah, looks like someone beat me to the punch. Let's see. C is for congestion. UA destination unreachable. There you go. This is actually the Cisco command reference here. I'm going to paste this into the chat room. Right there. Ping IPv6. Okay, so it's going to be somewhere in here. There we go. A means administratively unreachable. There is an access list blocking traffic. So it tells you exactly what's going on, which is pretty cool. I'm wondering if there is a way to change that, because you might not want the other side to know that you have a an access list blocking that. Okay, so you can see that access list is pretty cool. Pretty cool. Now, if we go back to R6, because we did this access list, so show IPv6 access list, because we did this with a /64. If I go into any of the interfaces and put like 6000 : 5 : 10, as long as it starts with 6000, it's dead. I can't reach it. Because the first 64 bits are the same. So it doesn't matter what the ending is, that deny statement is going to catch it all. Now if you want to match it exactly, we can change it. We can go into here on R6, and so let's be more exact. Let's go into IPv6 access list. Lakers suck. Yeah, I don't think they're going to make the playoffs this year. I'll be surprised if they do. So watch, I'll laugh if someone's watching this Hangout a year later and the Lakers actually did make the playoffs and they won the world championship. Then you could go into comments and say I suck or whatever, but I don't think they're going to make it. Okay, so sequence, we're going to just change the sequence number. That way we don't need to blow away the entire access list. We could do sequence 10, deny IPv6, any, going to 6000 : 6/128. So I'm going to match it exactly. So show IPv6 access list. So it says it changed it to host. I could have done host 6000 : 6. We go back to R1, and the pings are still dying, so we know, right? But watch this. Let's do this. Let's go back to R6. Let's do this. Now, if we go back into the loopback, now we may actually have a problem because that IPv6 address is actually a /64 if I remember correctly. So let's see if I can do a : 7/64. Oh, okay, I can. I was afraid it was going to give me possibly an error with the same subnet, but we're good. Show IPv6 address. Show IPv6 interface brief. Okay, so I just made another IPv6 address on that loopback 6000::7. Right, so since I'm matching exactly on ::6, I should be able to ping the 7. So let's check that out. Let's go to R1, Control-Shift-6, hit the up arrow, ping 6000::7, just do a repeat of 1, and that has a success. So here we're matching the host exactly. Now, in IPv6, you can be a real bastard because it's not like IPv4. When you block an IP, it's a little bit tougher to get another IP. But with IPv6, if you block, if you find that one IPv6 is blocked, it's not really a big deal to make another one. So chances are, whatever you pick will be available. Okay, let's see. We did tunnels, we did IPv6 addressing, we did access lists. Wow, that's everything that I was scheduled to cover, and we actually went through that fairly fast. Any questions about what we did tonight? The question is, do you still get the duplicate IP address error in IPv6 like in IPv4? So it's different because if it detects that another interface is using the IP address that you want, then the interface doesn't even come up. So we don't even get that duplicate IP address error because that DAD, the duplicate address detection, the DAD, slaps it down. So it's preemptive. It figures out the problem before there is actually a problem. Versus IPv4, IPv4 is just dumb, right? It goes, oh, okay, I'll just take this address, and then, whoops, we got a problem.